All right, everybody, welcome back. We're going to be talking to you today about electric current and magnetic fields. I'm Mr. Bremberger.
I'm Miss Agar.
And let's go to work, shall we? So, what exactly is electricity? You guys use it all the time. It's an often overlooked concept in school. So
Your parents have probably yelled at you before. Stop using so much electricity. Like
No.
You've heard that before.
yeah, mine have. Way too much Xbox usage, way too much TV. Well, by the time we're done, you're going to be able to calculate how much exactly you either spend or save on electricity. So, as far as electricity goes, it's all powered by the electric current, which is the movement of electrons from one atom to another. Oh man, I got cut off. Cool. Okay. So, electrons, ladies and gentlemen, have a negative charge. And our usage of that negative charge can help us make things move, or make things light up, or make our daily lives a heck of a lot easier. So,
Mr. B, I have a question.
yeah.
Why does charge even move? Like, what makes it move in the first place?
All right. Remember the concept of magnetism, with opposites attracting and like forces repelling. Same thing here. When we're talking about the movement of electrons or protons, what we're really interested in are the charges. Those electrons, if we put two electrons by each other, they're both going to move away from one another, which is like repelling each other. If we put a proton and an electron next to one another, they're going to attract, just like a north and a south pole on a magnet might. So, again, what we are ultimately interested in is this movement of electrons. Because if we bump an electron into one another, we can seriously get these electrons to move in a straight line. So what I have here are, 5 atoms lined up. Right? And if we can get this electron to move from there to there, the electrons are going to get ticked off, right? Because they do not like one another. So if this one moves from here to here, it may move that electron to the next atom, which may spark an electron to move to the next atom, and so on and so forth. Now, obviously we can harness that for multiple reasons. So, why don't you take a second, pause. If you want to draw this structure out, go ahead. Otherwise, we're going to move on, and I'm going to erase it.
All right, another question. How does charge flow from one place to another?
Okay, again, we're harnessing that hatred of one electron for another. So if we are able to get these things to move in that straight line, just like we did before, within a wire or within a circuit, we can then use it to our advantage. If you take a look at it on a bigger scale here, all these electrons lined up next to one another, wrong word, all these atoms lined up next to another. We can, again, by moving an electron from one atom to another atom, we can get these things to move within that circuit and use them to our advantage.
So when I plug my Xbox or my cell phone charger into the wall, into an outlet, the electrons are moving through the cord to my device?
Exactly. Right? It's all about the movement of electrons. Think about the word electricity. Most of it comes from the word electron. Right? So,
How does electric charge relate to magnetism?
well, people, an electric current will create a magnetic field. All right, you can go run a current through a coil of wire and use it actually as a magnet because of the movement of those electrons in one direction. One direction, right? So, totally lost my train of thought. Now,
Most of our kids do when they hear One Direction.
exactly. Oh my God. So, using that movement of electrons, we basically create one giant domain within a coil of wire or within a straight wire that will, again, be used or can be used as a magnet. All right, which brings us to the circuit. Okay, if we don't have a circuit in the proper order, we cannot get electrons to flow. So generally there's 3 different parts to a circuit, and we're going to get really deep into this in coming units. But we have, essentially we're going to need a power supply, we're going to need some wire or something to connect it all together, we'll need a switch to turn it on and off, and finally we'll need something to use the electricity. So again, to jot all those down, to get a really basic picture, again, that circuit will basically help you, control something that is powered by electricity. So, in your book, you've probably noticed the words conductors and insulators. And actually, in real life, you probably run across these as well. Conductors are really good at conducting electricity. Insulators, not so much. And the reason for it is because within an insulator, you don't have those atoms that are free to move as you do in conductive metals. So, things like copper, zinc, you have lots of free electrons in those metals that can move from one place to another and conduct electricity. Insulators like plastics and woods, they just don't have that ability because of the way they're chemically bonded together. So, Ms. Agar, we're going to play a game. You didn't know this, but we are. We're going to play conductor or insulator. So, eraser, what do you think? Conductor or insulator?
I would say an eraser is an insulator.
Definitely right. All right. How about a metal pen?
Considering it's metal, I'm going to say conductor.
She's right, 2 for 2.
Good at this game.
Paper envelope, conductor or insulator?
I'm going to go with insulator.
Excellent. All right, the insulator, paper doesn't conduct electricity very well. How about a pencil?
There is metal on the end of it, but it's wood. Still going to say insulator.
All right. How about both? You're exactly right. That wood part of the pencil, not going to conduct electricity, but the metal will certainly do that.
It's almost like you planned this.
Right. Oh my gosh, I gave you the answer. Paper clips, definitely a conductor of electricity because they're made out of
Metal.
metal. Exactly. How about chalk?
I'm going to go with insulator.
Excellent. Well done. All right. Again, difference between a conductor and an insulator. Conductors conduct electricity or allow electrons to move freely. Insulators, not so much. So, last concept I want to talk about today is the idea of resistance. Now, we are going to harness the resistance that exists within certain machines to kind of get in the way of the energy that's flowing within a circuit. Now, we got a picture of a karate guy running through a gauntlet, which is basically what your resistor is going to do. It's going to get in the way, resist the flow of electricity or the electrons moving within the circuit, and therefore maybe harness that electrical energy in some way. So resistors will interfere with that flow, and we use them to our advantage. Now think about some classic examples of insulators. We have light bulbs, hair dryers, toasters. Can you think of any others that may provide some resistance in the circuit?
Hair dryer is my favorite one on that list.
Curling iron, straightener. Folks, anything you plug in, iPad, anything that is going to get in the way of the electrons and either use them to charge something or basically convert that electrical energy into anything could be classified as a resistor. So, if you have any questions for us, please feel free to let us know. Otherwise, I'm Mr. B.
Ms. Agar.
We're out. See you.